right, hey everybody, welcome to another day of chemistry. So what we're going to start talking about today is we're going to start talking about the kinetic theory. So the idea here is that everything that we know of is made of particles, and the way those particles are arranged and the way they're moving kind of helps us understand what everything is. So the idea here today is I'm going to take you through a little bit about that. You should have already watched the video, the science revision about solids and gases, and you might have even filled in these particle pictures already. So let's go ahead and take a look at that a little bit more. So the particle idea, so let's fill it in together just in case you haven't already done so. So for solids, the idea is that your particles are going to be pretty close together. They're going to be organized pretty evenly, like organized patterns. That's kind of the solids ideas. Liquids then start to get a little bit more spaced out. They kind of start taking the shape of whatever container they're in. They're not as organized. And then gas particles are going to move super fast until they bounce into something. And then they're going to move somewhere else until they bounce into something. And there's a lot of space and they move all over the place. So that's kind of the idea between solid, liquids, and gases in terms of particles. So what I want to talk about next is what would we say are the properties of each state of matter? Properties are going to be things the way we describe them. Think like adjectives in the English world. So solids in terms of properties, solids are going to have their own shape. And the reason they're going to have their own shape is because of the particles being pretty attracted to each other. So we're going to say particles are highly attracted. So the reason they stay in the shape they are is because the particles want to stay in that spot due to the attraction between the particles. So because it keeps its own shape and the particles are highly attracted to each other, we would also say that it has its own volume. It's always going to take up the same amount of space. You can't smash it any smaller, those kinds of things, unless there's air inside it, but we'll get, that would be gas as a state of matter then. But the actual just solid thing is going to stay the shape that it is unless you change something about that piece of matter. So then let's do that same kind of idea and let's talk about liquids. So liquids then, the idea here, so liquids then, they take the shape of the container. This is why when you pour something into a glass or it spills on the floor or into a vase or something like that, it takes the shape of whatever you poured it into. So if you had something that was in a jug of milk and then you put it into a bowl, it changes the shape of the thing. And excuse me. The other thing that is interesting about it is that it also has its own volume. So that kind of that idea that if you had, for example, let's say you had 50 milliliters of water and it was sitting in a beaker and then it spilled onto the floor, it would change its shape, but it would still be 50 milliliters. And if you put that 50 milliliters into a swimming pool, you would still only have 15 milliliters. It would just spread out, that kind of idea. So it takes the shape of the container, but it has its own volume. It will only take up so much space. It's just the shape that can change. And then the other thing about it is that we'll say that the particles are kind of attracted to each other. Kind of attracted. This is why when you pour something, gravity helps take over, but the particles move with the other ones because they're attracted. So one liquid particle kind of pulls on the next liquid particle and they're kind of attracted to each other. And so that is liquids. Now let's do that same idea, but let's talk about gas particles then. So gas particles, we would say that these also take the shape of the container. Think of like a balloon or a gas cylinder. You put gas inside it, it fills up the space that it has. And because it fills up the space that you give it, we would also say that it takes the volume of the container. So again, if you have a type of balloon that's in a certain shape, and then the whole thing gets filled up, it's going to take up however much room it has. This also is because the particles are moving so much, and the reason they can move so much is that we're going to say that the particles have almost no attraction. And because of that, then the particles can kind of move over the place. This is why, like, say someone is wearing really, really strong perfume, you can smell it even if you're not sitting right by them, because those particles are moving as much as they can. They will spread out as much as they can. That's because they take the volume of whatever shape they're in, whether it's a full room, again, like a gas cylinder or a balloon, or that kind of stuff. So this is what we would say are the things we know about any state, or the three states of matter. These are the things that we know for sure, whether it is something that is a dangerous chemical or a type of food or a cleaning product, it would match these things. Okay. So those are our states of matter. Now, the next thing I want to talk about is, well, what if we change the state of matter? Because that's also going to be something that's pretty common in our world. It doesn't stay a solid. It doesn't stay a liquid. So if you have something that is solid and you want to move it to liquid or move it to gas, you need to add energy. So capital E for energy. And the reason that works is because as the particles have more energy, just like when you have more energy, the particles are going to move faster. And because they are able to move faster, they spread apart. So they're no longer as close as they were together. And then because of that, they're less attracted to each other. So because there's more space, they're not noticing those attractions that used to be keeping them together like a solid, until you get all the way to gas, where those particles are moving so fast, they're so spread apart, you don't even really notice their attractions at all. So then if you wanted to do the opposite, if you wanted to go from a gas to a liquid to a solid, well, then it's all of the opposite. You need to remove energy, which you probably predicted. And then because doesn't have as much energy, then the particles are going to move slower, you guessed it. And then this makes them move close together. And because they're closer together, you're going to start to notice those attractions. So move closer together, more attraction. Now, just to clarify, the attractions are just noticed more than they were before. And then that's what pulls those pieces together. That's why there's less space. And then that's why you'll get from that liquid to solid. So moving. So if you're thinking of like freezing water into ice cubes, that's kind of the idea there. All right, and then the last relationship I want to talk about is the relationship between temperature and kinetic theory. So kinetic theory is about these particles, right? And then what happens is those particles, when they have more energy, then you're going to have a temperature that is higher. So really a temperature is just a measurement of how much energy there is. So if you think of like the temperature of like boiling water or the temperature of snow, it has to do with how much energy those particles have. And so they have a difference in energy because they have a difference in motion. So that's what I wanted to take you through, just to sort of give you some background about some of this kinetic theory stuff. And what I want you to do next is I want you to do this computer exploration. Now you can see what the objective is. What you're going to be able to do is you're going to be able to understand the relationship of particle motion, and especially gas particles and gas sizes, and also the difference between solid, liquid, and gases. This computer simulation doesn't work on the iPad, so what you're going to do is you're actually going to go to the desktop computer lab that's right behind our classroom. Use your iPad, though, to answer the questions and guide your work. And then if you have any questions, just let Miss K know. Thanks. Bye.